Yeah, so the Polaris is a type of a giant star. So it's actually 46 times the size of the sun.
Wait, hold up. You said that the star Polaris is 46 times bigger than the sun? The sun is so massive though. How is Polaris so big? How is this star, also known as the North Star, so massive? Well, Polaris, the North Star, is very, very special to humans on Earth because of navigation purposes and so many other things. But what does the surface of Polaris even look like? And how have scientists from the CHARA Observatory, GSU CHARA Observatory, how have they been able to image the surface of Polaris? And what have they concluded through those images of the North Star? Well, in this episode, I'm going to be talking to Dr. Gail Schaefer. Dr. Schaefer is the director of the GSU CHARA Observatory, knows a lot about Polaris, CHARA Observatory, how it works, and all about Polaris, the North Star, and what's so special about this amazing star. Let's get right into this interview. Trust me, there's lots of interesting facts that you'll learn. So let's get right into the episode. Let's go. Hi, Dr. Schaefer.
Hi, Ashke.
How are you?
I'm doing well. How are you doing?
I'm doing great. Thank you so much for joining me today.
Yeah, thanks for inviting me. It's great to be here.
Thank you so much. So can you please introduce yourself to the listeners?
Sure. So I'm Gail Schaefer. I'm the director of the CHARA Array of Georgia State University. So the CHARA Array consists of 6 telescopes located at Mount Wilson Observatory in California. So these 6 telescopes are spread across the mountaintop, and we send the light from each telescope across the mountain into a central laboratory where we combine the light from all of the telescopes together. And this allows us to use the CHARA telescopes acting together like a giant 300-meter telescope so that we can see very fine details when we look at the sky. So ordinarily, when you look at a star through a telescope, it just appears as a pinpoint of light. But by using the CHARA array, we can actually start to image the surfaces of stars other than the sun.
Wow, and that's what you've imaged recently, the Polaris or North Star. And we'll get to that in a little bit. But first, how did you get interested in science?
Yeah, so I was always interested in science as a kid, but it wasn't until I went to college that I decided to pursue science as a career. So I originally went to college and I wanted to major in psychology. But at the same time, I started taking some physics classes and I found that I really enjoyed taking those classes. And so one day I was talking to one of my physics professors who just asked me, why aren't you a physics major? You're taking all these classes. And so it gave me a lot to think about. And so eventually I decided that, it was a good calling and I really enjoyed the physics. So I switched majors. And from there, I decided to focus on research in astronomy when I decided to go to grad school.
And that's how you're the director of the CHARA Array, which is so amazing. All this science is going on in space. You're able to see it right here from Earth. It's so awesome.
Yes, definitely.
All right, now let's get into the recent news about Polaris. But first, for people who don't know what exactly the star Polaris is, they might recognize it by another name, North Star. So what is Polaris or the North Star and why is it so significant?
Yeah, so Polaris, or the North Star, is located at a special place in the sky. It is basically located right along the direction of Earth's rotation axis. So because of this, the Polaris appears like at a fixed location on the sky. So when you go outside and the Earth sits spinning on its axis, all the stars appear to rotate around Polaris in the northern sky. And when you go outside and you happen to look up at the sky and you find Polaris, it's a way to know that when you're pointing towards Polaris, you know what direction north is. North is always pointing towards the direction of the North Star. So Polaris historically has been used as a navigation aid. And then there's some additional special characteristics about Polaris also. First, Polaris is a type of star that we call the Cepheid variable stars. And so these types of stars are pulsating variable stars. So this basically means that Polaris is getting brighter and fainter as the star itself, the diameter expands and shrinks and expands and shrinks over a 4-day cycle.
Oh wow.
And yeah, and so these types of stars can be used to measure distances to faraway galaxies if you measure that pulsation period. Brighter stars tend to pulsate very slowly, and fainter stars pulsate quicker. So it's a way to like know the true brightness of a star in the sky. And then another piece of interesting information about Polaris is that it's actually the brightest star in a triple star system.
Oh, wow.
So yeah. If you look at Polaris, yeah, 3 stars, and they're all kind of orbiting around each other, just like, the planets orbit around the sun. So instead, Polaris has 2 stars that are orbiting around it. So one star is very far away, and if you look at Polaris through a small telescope, you can see the wide companion, and then it has a very close companion that orbits Polaris every 30 years. And this close companion is very faint and very challenging to actually detect in telescopes.
Wow. So Polaris has this entire star system that's surrounding it.
Yes.
Wow, that is so cool. It's like the sun and its planets, but instead it's a star orbiting around another star, and there's 3 stars in total in that entire system. That's mind-blowing.
Yeah, it's very exciting.
So how did the team of researchers use CHARA to image the surface of Polaris?
Yeah, so when we observe stars with the CHARA array, we don't get direct images of what the stars look like. So what we do instead is we record what's called an interference pattern. And so basically we're looking at the light, and there'll be bright and dark bands of this interference pattern. Basically, these interference fringes contain information about the size and the surface features on the star. So after we collect data with the CHARA array, we can use a computer program to turn this interference pattern back into what the star actually looks like. And so this is what we did with Polaris.
So what did your team find through the images of Polaris?
Yeah, so when we started looking at Polaris, what we originally wanted to do was we wanted to map the orbit of this very close companion of Polaris. And so we did succeed in imaging that companion, but we also started noticing that there was more features in Polaris than we expected. And so when we made the image, we discovered that the surface of Polaris has these bright and dark spots on the surface that appear to change over time.
So why do these spots change over time? What does that tell us about the star itself?
Yeah, so these spots on the surface of stars are usually created by magnetic storms in the atmosphere of the star. So this is similar to like sunspots on the sun, but these star spots on Polaris are much, much bigger. So very, very large magnetic storms in the atmosphere of Polaris. And so one of the next steps is to look in detail at these spots over time and kind of try to learn about what's creating these spots on Polaris. So one of the things that you can do is that if you look at the star spot over time, you can start learning about the rotation period of Polaris, how many days it takes for it to rotate around, and you can see the spots going in and out. And we can also try to see if these spots are linked at all to this pulsation, that the diameter of Polaris is increasing and decreasing over time. So far in our initial investigation, we just got a few images of Polaris spread over several years. So one of the next steps will be just to look very systematically to learn about different patterns we can see in how these star spots change over time.
So you mentioned that the magnetic storms on Polaris are much bigger than the magnetic storms on the sun and sunspots on the sun. How big is Polaris compared to our sun? Is it smaller or is it bigger?
Yeah, so the Polaris is a type of a giant star. So it's actually 46 times the size of the sun.
Wow.
So, yeah.
That is massive. I thought the sun was big because compared to Earth, even Mercury, even Jupiter, the sun is giant, and we know that all the planets could fit inside of the sun itself. But Polaris, 46 times bigger than the sun. Wow, that is just mind-blowing and just stellar science right here.
Yes. Yeah, and the sun ends up being in relative sizes, a fairly small size. Even to us, it's huge.
Does that play a part? Does that play a role in why it's so visible from the Earth and why it's been used for navigation for hundreds and thousands of years?
Yeah, yeah. So the Polaris being such a bright star is it definitely helps in it being bright in the sky and easier to find.
Mhm.
And then in navigation, it is more just like the that Polaris just happens to be at this special place that's lined up with the Earth's rotation axis, so that it kind of stays fixed as all the other stars kind of rotate their position over the night.
Wow. And also about the position of Polaris, I've heard that the North Star might not be a true North Star anymore in maybe hundreds, thousands, tens of thousands of years. Is that how it works? Is it because Earth is moving and these stars are moving further and further apart because of the universe expanding?
So yeah, it actually uh, so the Earth spins, and just like if you have like a spinning top, sometimes that top starts to wobble around a little bit, and
Hmm.
so the same thing is kind of happening with the Earth's rotation axis. That the Earth is spinning over time, but its axis is actually wobbling a little bit. So over like tens of thousands of years, the Earth's rotation axis will point at different locations in the sky. And so over time, um, Polaris will no longer be the North Star, and we'll have a different North Star in tens of thousands of years.
Well, that's way
Just
past our
because,
lifetime. So we will still have
yes,
Polaris. We'll still have our favorite North Star.
yes.
So why is it important to study stars in such detail and what can we understand from that?
Yeah, so by studying the stars like Polaris, we can learn more about these pulsating variable stars that change over time. And so this is important because astronomers use these types of pulsating stars as what's called a standard candle. And so the standard candle is basically that you can pick out stars in the sky that you know are a certain brightness. And so when we see a star in the sky, the brightness that we see depends on how bright the star actually is and how far away that star is from us. So if you have a very big bright star, it'll appear brighter. But if you move that big bright star farther away, it's going to appear dimmer. And so these pulsating variable stars, because we can measure how their brightness varies over time, and it gives us an idea about their true brightness. So then when we measure that, like their pulsation period, and then we measure how bright the stars appear, we can then use them to measure distances to the stars and to the galaxies that those stars might be in.
Wow,
So
so it basically serves as a benchmark to in order
yes,
to measure these distances, the vast distances in space.
yes, yeah, which is just an important part in like putting the whole scope of the universe together. And
That is so amazing, all the research that goes into that. Because I've always wondered how do we know exactly how far this object in space is from this object? So I guess using all these types of stars and studying things using telescopes really helps with measuring those distances across space.
yeah, yeah, and there's a number of different techniques that you can use to measure distances, and these pulsing variable stars are just one of those techniques that astronomers use.
Well, that's so cool. So, now, what advice do you have for kids who are interested in science and want to go into a science profession or a science field or even space specifically?
Yeah, so I think the first thing is that I would recommend taking a variety of math and science classes. So it turns out that a lot of science involves fitting mathematical models to explain your data. So having a good math background ends up being very important. I would also recommend learning some computer programming. So computer programming, especially in astronomy where you're working with digital images on your computer, knowing how to write computer codes is a very valuable skill. And finally, I think I would recommend, if you have the opportunity, to get involved in research projects at an early age. So this might be, through opportunities available at your school, or sometimes even local colleges will offer internships for, high school students. And so getting involved in research early would provide a great experience to build off of in the future.
Well, that's some great advice for these up and coming generations of scientists. Hopefully, they might discover the new North Star in the future.
Yes.
Yeah,
Space is big, and there's a lot of discoveries to be made.
yep, definitely. There's endless amounts of discoveries in this universe. Thank you so much for joining me today, Dr. Schaefer. I really enjoyed it. I learned so much about Polaris, the North Star, and about all these breathtaking images that your team has collected and how you use those images in order to determine lots of different things. And the science behind all of this is really amazing. So thank you so much for your time today.
All right. Thank you so much for having me. It's been a pleasure.
Thank you so much. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science produced and hosted by me, Akshay Raman. Our theme song and additional music are by Chan Ramachandran. Special thanks to Dr. Gail Schaefer for accepting my interview invite. Dr. Schaefer, I learned so much in this episode, and I learned so much about Polaris and all the amazing discoveries you and your team are doing. Thank you so much for joining me today. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you want answered on a Spectacular Science episode and get a special shout out? Or grab an adult and head over to spectacularsci.com/contact. There you can find a contact form and you can send me your amazing science questions. Thank you so much. Also, don't forget to subscribe to this podcast wherever you're listening right now. It really encourages me, and you'll be updated on all the new episodes. So subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.